My name is Professor Duke Orata. We are continuing with our lectures on jet propulsion. Remember last time we talked about turbojet engines and ramjet engines. And today we are continuing with rocket motors. And rocket motors, unlike in the case which we had looked at previously, and I keep encouraging you that you go through our lectures systematically. We have said that one depending on atmospheric air as fuel. Now in this particular case, in the case of the rocket motor, the propulsion unit has its own fuel. The propulsion unit has its own fuel. I repeat this, unlike in the case of turbojet engines or ramjet engines, where atmospheric air was critical. In this particular case, the propulsion unit has its own fuel, and that's critical. That's very, very critical. That's why these rocket motors will find use in cases of high altitude or outer space. This makes them handy in those cases of high altitude or outer space excursions. Now, there could be, that particular fuel can be solid fuel, or we can have liquid fuel, for example, and a good example here would be a case where we have kerosene, example. In case of liquid fuel, we do kerosene together with an oxidant. The oxidant can be nitric acid or hydrogen peroxide. Examples would be kerosene and oxidant. And the oxidant can be nitric acid, or it can be hydrogen peroxide. And it is important to mention that in this rocket motor, we normally have in general a combustion unit and a propelling nozzle. You have in the rocket motor, we have combustion unit and a propelling nozzle. Don't forget, when we talked about cases where we have the atmospheric air playing a critical role as the oxidant or the fuel, we said that the turbojet engines, we had the diffuser, then we had the energy unit, which was the combustion chamber, and we also had the nozzle. And the ramjet, basically, we had in the combustion unit. And the combustion unit in the turbojet engine, we had said that there we could have a compressor, then we have the combustion unit itself, and a turbine. Remember that? And in the case of ramjet engine, we didn't need a compressor or a turbine. It was not necessary. We just also had the combustion unit and the propelling and the diffuser. Now, in the rocket motor, we have the combustion unit and the propelling nozzle. So it's very critical and important for us to note that. So that in general, in this particular case, the fuel actually can be mechanically pumped into that combustion chamber, can be mechanically pumped into the combustion chamber, or you can use compressed nitrogen to achieve that particular process. So in the rocket motor, the fuel can be mechanically pumped into the combustion chamber. Mechanically pumped. Mechanically pumped the combustion chamber. Or you can use compressed nitrogen to achieve the same result. And therefore the schematic which will illustrate this particular system, the schematic which will illustrate this particular system, that particular system will simply be characterized. In the case where you're using compressed nitrogen, we'll have our compressed nitrogen. Then of course we'll have our liquid fuel, that is kerosene. And of course we have our oxidant. And our oxidant, we said, was nitric acid, or can be hydrogen peroxide. And you have a converging divergent nozzle. So what kind of system do we have here? We have this system. The other one here. So we have that kind of a system. We have the compressed nitrogen, so we can actually pump the fuel into combustion chamber using compressed nitrogen, or it can be done through mechanical pumping. And normally, this combustion chamber can withstand very high pressures. Note, the combustion chamber can withstand very high pressures. Maybe 20 bars. Think of that. And so when we have this very large pressure drop, in the nozzle, it will lead to very high jet velocities. So due to the large pressure drop, in the nozzle, we have high jet velocities or large thrust. High jet velocities, large thrust. So, we have introduced ourselves to the concept and the unit which you call the rocket motor. And the important thing is to notice that in the rocket motor, like in the case where atmospheric air was the propulsion fluid, here the unit has its own propulsion fluid. And so it can be solid, can be liquid, and like I've said, it makes it very handy to use at high altitude or in outer space. And so we have said in the combustion chamber, you have the combustion chamber and you have the propelling nozzle, and you can actually pump that fuel into the combustion chamber mechanically, or you can use compressed nitrogen to achieve the same results. And because of those pressure drops, very high jet velocities and high thrust and so forth. And so this, we just introduce ourselves. In the next lecture, we're going to go into further details on these rocket motors. Let's meet next time.